We're going to take a look at inequalities in a triangle. Now, we've kind of seen this and talked about this, and hopefully you are aware of this, that when you have a triangle, that the measures of the angles are related to the length of the sides. That hopefully seems relatively apparent to you. So, what I'm going to do is I'm going to give you a moment here, and I want you to make sure that you have these things down. All right. Now, observationally, it's one side of a triangle is longer than another side, and the angle opposite the first side larger than the second side. Observationally, this shouldn't be a problem for you to identify. And the nice thing is, if you see that you got a small angle, you know the small side is opposite. You see you've got you got a small side, you know the small angle is opposite. That's just the way it should be. But that's observational, right? So if I want to order the lengths of these sides from least to greatest, what's the smallest side? Well, does it help knowing what a missing angle would be? So what would be the measure of angle C? 80. So we know that's going to be 80 degrees. So the smallest side here would have to be what? Side. So if the angle is 40, what's the side opposite it? BC. I know, I probably didn't hear you shout that. So what would be the next longest side? AC. And of course, then that means that the longest side would end up having to be BA, from least to greatest. Not that difficult of a deal. What about here? Which one of these angles is going to be the smallest? I don't know. That's what I'm asking you. Oh, angle Y. Thank you. So angle Y is the smallest. Then what comes after that? Okay, angle Z. So that means that angle X has to be the next largest. I don't know what the numbers are. I just simply know that that must be the case based upon the information I see on the length of the sides. I mean, think of a scissors when you're cutting. Scissors? Scissors. Ah, scissors. There we go. I mean, if I open it up and I just got a small angle on it, the distance here isn't very much, is it? If I open it up like that, larger angle, larger amount to cut. There it goes. Obvious, right? Laugh at me. Okay. I should get a haircut? Oh, Jacob. Okay, I'm going to give you a few moments to get this one taken down. All right. 20 degrees are in a triangle. So if you add up all the angles, you get 180 degrees. What about when you have a line and a line coming off it such you have a linear pair? What does a linear pair add up? Now you're guessing, but yeah, 180. So let's take a look at this. They were good guesses, though. Now, we know that angle A plus angle B plus angle C equal 180 degrees, right? What does angle X plus angle A add up to? Well, aren't these a linear pair? Aren't these supplementary? Don't they same side of a line? You got to remember these terms. That's why you should have them written down in your little book. That's why you've got that access to all those definitions and theorems in Google Classroom. That's why it's there. So, for those of you that weren't paying attention, what would happen if I got rid of this x or that angle there and that angle there? They'd be gone, yes. It wouldn't be equal to 180 degrees anymore. But what I'm going to do is I'm going to go and do this here real quick. Back up. And I'm going to rewrite this as angle A plus angle B plus angle C is equal to angle X plus angle A. Would you agree with that statement? Yeah. Now, if I get rid of the A's, I've only got angle B plus angle C is equal to angle X, right? So if those two add up to X, does angle B have to be less than angle X? Does angle C have to be less than angle, angle X? Because X and C or C and B add up to X. So it's this understanding and the connections that you have. So, give you a few moments, let you ponder this one. All right. Here's an idea for you. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So, if I've got a triangle that's 3, 5, and 9, can I actually make a triangle that's 3, 5, and 9? That's the question. So, we'll try and make a triangle that is 3, 5, and 9. So, we got this here. Make that one 3. Make that one 5. I'll make that one 9. Okay? So I've got lengths 3, 5, and 9. Now I should be able to make a triangle out of that, right? You what? You doubt? Why do you doubt it? Because you read the theorem? You were supposed to say yes, because I read the theorem, I understand the theorem, I know the theorem. Yeah, but is there any way that I can arrange these lines such that it would ever connect? How? I cannot. They're straight lines. I can't do anything with it. Now I can connect this one maybe up over here. Okay, but I don't have, but that's not a length of side 9. That's all 9, but it's sticking out over here on the edge. I can't do that. Yeah, I know, but that's not a triangle with side lengths of 3, 5, and 9. You can come up with all the silly little answers you like, but it's not going to change it. There is no way that I can connect these two. Okay? You'd never be able to connect the two, connect the shorter sides. The two shorter sides always have to add up to more than. If can't be equal to, because then they're going to be the same. Well, think you ever take cards and you make little tents out of the darn things? Yeah. So if you take two cards and you put them together, is the distance between the bottom cards that are sitting on the platform, is that shorter or the same length or longer than a card? Huh? Same length? Okay. So if I were to go and do that, now you said if they were add them together, but that means that the cards would be laying flat, wouldn't they? All right. So let's try this. Okay. Let's decide whether or not I can actually make these triangles. So I got 3, 4, 5. If I go and, okay, so I need a 3, I need a 4, and I need a 5. Okay. So if I take those, is it possible for me to come up with some way of arranging these into a triangle? Okay, so, but I could play around with the angles and everything else and move them around so it would happen, right? You agree with that? So, let's see. Now I need to make a 5, 11, and a 6. So here's my 5. Set those over there. Set that over there. So let's see. Now I need to make myself an 11. Yeah, you'd end up putting yes, yes, or no. There's my 11. Would you agree with that? I had to put 2 of them together, but that's my 11. And then I need a 6, right? Why won't it work? Okay, so triangle, you know, we got to have something at an angle there, so I'm going to undo that. Sorry. Okay, so I put an angle on that one. Move that one over there. Well, let's see, I could probably go and move this a little bit differently. Okay. But would they ever make, oh, hold a sec, there we go, I got to get it back over there. Would they ever touch though? Yeah, when they're straight, when they're down, because if this is 11 and that's 6 and that's 5, 5 plus 6 is 11. It's just like that whole card thing again. If I have 2 cards, I would need 4 cards. I'm going to make this pencil. Okay, so that would be a no. What about a 1, 9, and a 5? Oh, definitely not, because let's see, we said we needed a 9. I don't have a 9 there. Still got my 5 there, so get rid of this one. Get rid of that one. Fine, be that way. Take U. U. Delete. 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 I said I needed a 1 and a 9. So I know. So there's my 9. There's my 5. And if I put my 1 down there, is there any way that I'm ever going to get close? No. What? There's no way that I can do it. You okay there? Okay. So now my next question comes basically off that idea. They want us to find the range of values for x in the given triangle. So what is the smallest? What is the smallest that it could be? And what is the largest? Oh. What is the smallest that it could be? 3. Well, could it be 3? Okay, but if you said it's 3, if you say the smallest is 3, what's 3 plus 4? So would that x have to be larger than 3? It would have to be bigger than 3, otherwise you wouldn't have a triangle. Okay, so if it was 11, it would have to be smaller than 11, wouldn't it? Yeah, 7 plus 4 is equal to 11. So if I had that as 12, would 4 and 7 ever get to 12? No, never get out that far. It wouldn't touch. It wouldn't make it to that point. So the smallest is 3, the largest is 11. So you take the sides and you subtract, smallest. Sides add, largest. Yeah, it would have, but you'd have to write it like this, where 3 is less than x, which is less than 11. That's how we would write the range. So, took a flight from Atlanta to London. So if I say that Atlanta is down here, London is across the puddle over here someplace, right? So we go all the way over there, and that is going to be 4,281 miles, yes? Now, is New York north of Atlanta? Okay. So say New York is right about there. And this distance over here is 3,470. And then it says that flies back to Atlanta. What is the greatest that she could have traveled? What is the least she could have traveled? Well, if we want the smallest value, wouldn't that be 4,281 minus 3,470? Okay. So whatever that number is, that'd have to be the shortest distance. Okay. So it would have to be larger than that. And then over here for the larger one, wouldn't I take 4,281 plus 3,470? Come up with that answer? That's it. All it is. So what I'm going to do here is I'm going to give you a minute or so, and I want you to do this particular problem. All right. So which one of these is going to be the smallest side, Parker? FE. Do you agree with that? If you don't, well, EF, FE, same thing. Okay. So what should be the next side then? So you were telling me no to FE, so you said EF. What's it supposed to be now then, sir? Huh? DE? Oh, I would think that you'd have to be wrong because that's ED, right? Ooh. Okay. Yeah. Yeah. You. Okay, that brings up an interesting question. Should we go and put our letters for these things in alphabetic order? Generally speaking, yes, we would like to see things in alphabetic order, unless we are using something specifically to identify that this goes with that, and we are unable to do that. So yes, technically you should have EF. Technically ED would be correct. So does that mean that the last one would have to be DF? Okay, good. So take another minute and do this one. So, Hannah, what is the smallest angle? Okay, so we get angle Q there. Healy, what would be next? Oh, you mean angle P. There we go. And of course, that means that angle R would have to be the last one, correct? Was there any other way that I could order them then? Okay. So, give you a moment or so here, and I want you to take a look at this and see what you come up with. Okay, so show that in triangle, the measure of the exterior angles at vertex Z is greater than the measure of angles at vertex A or X or Y. So I trust that you did something like this, that you took angle X plus angle Y plus angle Z and said that was equal to 180, yes? Then you did something along the lines of angle A plus angle Z is equal to 180. Okay, you got to have that information in there. Then somewhere along the line, angle X plus angle Y plus angle Z has to be equal to angle A plus angle Z, right? And then we would have to get down that angle X plus angle Y is equal to angle A. Got rid of them. So, since that is the sum, and those two numbers must be smaller to add up to angle A, angle X has to be less than A, and angle Y has to be less than angle A. So if you go through and do this logical argument, does that show that this is the case? Now, mind you, there's a difference between show and prove. Prove would require that we make sure that we put in all of the statements on there and use the appropriate theorems. This is show. So, there you go. Give you a moment or so and do this. All right. So, let's see. Yes, Parker. You got it? What do you got? Is what? So 50. So X has to be bigger than 50 and smaller than what? Okay, so if it has to be bigger than 50, it also has to be smaller than what? Absolutely correct. You subtract the values, that's has to be bigger than the smallest. You add the values, and it has to be less than that. There you go. So, I'm going to let you guys get to work. This is due at the end of class tomorrow.